Great, thank you. We'll move on to our third talk of the session. This is by Davis Conley, Living Through Dead Days.
Hey, my name is Davis Conley. I'm a volunteer with SIL International. We're the foremost authority in the world on human languages, and we're a faith-based organization that works with communities around the world on language development. And our core competencies are Bible translation, literacy, education, language development, linguistic research, and language tools. In 2023, you shouldn't be surprised that language work is done mostly with computers, which require electricity. And I work with the Field Systems Group in Waxhaw, North Carolina, where we make small solar power banks to power laptops, tablets, cell phones, BGANs, and starting this year, Starlink. Next slide, please. My project last year was to determine how much solar energy is available for our power systems, and I developed a tool called SIL, the Solar Installation Lookup Tool, that used the climatological data. And it's a Google-based product that gives you on-demand access to the API to determine for a given location and solar panel orientation how much sun you'll get on your solar panels. Next screen, please. So after I completed that project, a colleague of mine said, well, how do I use SIL to find the number of consecutive cloudy days? And the answer is, well, you can't. So I began to dig further into the data to see what I could do. I found out that the no sun parameters at that time were not available. We looked at the cloud amount, and that turned out to not be very good. We said, well, maybe the energy should be less than a peak sun hour per day. That turned out to not to be very useful. And then we said, well, maybe we should be less than 20% of the average peaks and hours per day. And any type of averaging turned out to make all the cloudy days look like they were okay, which wasn't useful. So we had a better idea. We decided to compare the amount of energy that was available from the sun to the amount of energy that we actually needed for a given situation. And we came up with this idea of a thing called a dead day, which is a period of consecutive 24-hour periods that where the energy that you need is less than the energy that's available. So it's a running average over a certain number of days. And to accommodate that, I added some new input fields to my program, starting and ending year, the solar panel size. In my example, I'm going to use 100 watts here. The daily energy required. In my example, I'm using 100 watt hours. And then the number of consecutive days that you want to be considered one dead day. Most of our systems are designed to last 3 dead days on batteries. And so, or excuse me, 3 days. So we consider that if you go 4 days in one dead day, your batteries would be dead in that particular time. Next screen. This screen is the detailed information that you get. If you look on January 6th of 2017, you can see that it was 98% overcast, that you got 1.18 peak sun hours on the panels that day, and it produced 180 watt hours of energy, which is only 72% of what you needed. If you go all the way over to the right, you'll see that in that month, there were 4 sequences of 4 days where you had dead days. But this turns out to be too much information. So I've got another table that summarizes it for you. Next slide, please. And it shows you here that in January of 2017, there were 4 dead days in that particular month. And on average, for this 5-year period, you had 5 dead days per year. And next slide, please. I kind of also worked the calculations backward to say, okay, given that my panel size is fixed and my loads are fixed, how can I reduce my dead days to 0, which of course is what you want to do. And the cheapest way to do that is just start shedding your load. And you can see that in January of 2017, you would have had to reduce your load from 150 watt hours to 127 watt hours. Over these 5 years, the absolute worst day or month is in December 2021, where you would have had to have your load down to 74 watt hours. Next slide, please. The next best way to reduce the dead days is to increase your panel size. And here you can see that again, in January 2017, you'd have to increase your panel size to 110 watts. And all over those 5-year periods, again, December 2021 is the worst. You would have had to double your panel size to 205 watts. Next slide, please. On my product, I've added a couple of sliders so that you can just play with adjusting the panel size and reducing the load. You can mix and match those until you find the sweet spot of what you can afford to build. Of course, you could increase your battery storage by increasing the number of days in a dead day. But again, battery storage is the most expensive component of a PV system, and you want to try to find other ways to do it. Next slide, please. The way we're actually using the power products is we are on demand querying the downward irradiance and the diffuse irradiance and the cloud amount, and then applying the solar calculations from the paper Dr. Stockhouse et al. And doing those hour by hour. And then we're using the number of dead days that we see for a given location to inform the design of our solar power systems to ensure that our customers can live through the dead days. Next slide, please. We're only recently getting started with using the dead days feature of SIL, but we hope that knowing about the worst days of solar generation locations around the globe will better enable us to deliver correctly sized and cost-effective PV systems to serve the off-grid language communities. And we want to thank the power team for making this data available. It's been very helpful to us. Thank you.